Hi, Fraser.
I think we'd have to go with Chicken Man if we did that.
Sure.
Research it. It's great.
Chicken man.
Yeah. All right, number 12, number 10. That was mean. What's up with the meanness today?
Try to steal my man.
Okay, let's be honest.
All right, number 10.
Who's going to go to prom with anyone who would be?
Obviously you.
All right. Number 10. Two horizontal forces, F1 and F2, act on a 4-kilogram disc that slides over frictionless ice. So I think this, I don't know if the problem on this, so sorry, this is 6.1, number 10, for those of you keeping score, and for me editing videos. So it says two horizontal forces, F1 and F2, act on a 4-kilogram disc that slides over frictionless ice on which an XY coordinate system is laid out. I believe that horizontal there means in the XY plane, right? Because like in this room, everybody point horizontally for me. Well, anyway, this way is horizontal, right? You guys agree with that? Right?
It says stop it on an XY coordinate system.
Right. So I think it might be misleading. Like Jake got tangled up on this for, I think, number 9. I think horizontal just means parallel to the ice. Okay? Not necessarily along the x-axis.
That's number 11, but yeah.
Does that distinction make sense? Oh, it was number 11. Okay. All right. So hopefully that's right. Let's see. So two horizontal forces, F1 and F2, act on a 4-kilogram disc. So mass is 4 kilograms. Force F1 acts in the direction of the positive x-axis. So F1 equals, let's just call it F1I. F1xi, I guess, right? Oh, it has a magnitude of 7 newtons. So I'm being dumb. So this. Oh. So do you guys agree that's F1?
Yep.
Notice my notation. I'm keeping track of the direction of the force by indicating I there. Force 2 has a magnitude of 9 newtons, but it doesn't tell us the direction. The graph at the right gives the x component, Vx, of the velocity of the disk as a function of the time during the sliding. What's the angle between the constant directions of forces F1 and F2? Okay, so then you've got this graph. Why do you think that graph is given to you guys?
So you could find,
To find the slope, to find the acceleration, right? So, right, because force has to do with acceleration. It's a velocity time graph. So the velocity is telling us how quickly the graph is telling us how quickly the velocity changes. That's acceleration. So let's pick 2 points on the graph. So I'm going to just pick the first and the last points. So it looks like my VF then is 5 meters a second. My VI is -4 meters a second. The time is 3 seconds. So I'm looking at an acceleration of 3 meters per second squared by picking the first and last points on the graph. Does everybody agree with that?
Yep.
Now, my notation is bad. Why?
Because it doesn't state AX.
Good. The graph doesn't actually give us the actual acceleration of the object. It just gives us the, or velocity, it just gives us the x component. So what I just found here is the horizontal component of my acceleration. Follow?
Yeah.
So what can I use that information to find, you guys?
How many newtons are you going in the X direction?
Yeah, so the idea is I've got this block, right? So here's my mass, 4 kilograms, right? I know that F1 is 7 newtons, and then there's a mysterious F2, right? So basically what I can do here is I can do net force equals net force. So here we go. Let's do net force X equals net force X. So let's see, net force X. So mass is 4 kilograms. Acceleration is 3 meters a second squared. That's got to equal 7 newtons plus F2x. Does that make sense, you guys?
Yep.
In other words, force 2 has some x component that we don't know. So you get 12 equals 7 plus the x component of x, or the x component of force 2. So it looks like the x component of force 2 must be 5 newtons. Follow? Positive or negative? Positive, right? Oh, and I also know the magnitude of F2, right? So now I can figure out the y component.
Just ask for angle.
Or actually, I don't even know if you have to do that, right?
Just ask for angle. So you
Yeah, all you need is the angle. So I know that my F2x is 5 newtons, and I know the hypotenuse is 9 newtons. I don't know whether it goes up and forward or down and forward, but it's arbitrary, right?
Yes.
You guys see what I mean? Like, it doesn't matter, because whether I draw up or down, I'm still going to find the same angle. So let's draw up, and that way we have less angles to deal with. Oh, let's draw it down so that it doesn't go through where I wrote F2x. So there's F2, it's 9 newtons. Here's F2y. And now you can just do what? Inverse cosine and find your angle.
Yep.
Does that make sense, you guys?
Yep.
Problemos? Questiones? Concerns?
Great group test.
Super desks?
Oh, that's me.
Oh, you have.
It's the mega desk.
Oh, it's the mega desk. My bad. All right. Is everybody good? Is it related to the mega bus?
No, it's from the office.
Oh, is that a thing?
Yeah.
What is the office? Is that a radio program?
You don't know the office? You're too young.
Yeah. All right. Everybody good?